In this video, I'm going to be showing you how to build out a full stack AI application by leveraging co-agents by CopilotKit, as well as a Python cognitive architecture that's built within LangGraph. By the end of the video, you'll have this Next.js application that you'll be able to have a research helper where what you'll be able to do is you can put in your research question, as well as ask questions within the Copilot pane here on the right-hand side, and it will ultimately generate a draft for you. So within this, you can leverage models from OpenAI, Anthropic, or Google. In this example, I asked the question of how will Google's new Willow quantum computing chip affect Bitcoin security? This is less about the question about that, but more just to show you how you could potentially have your own tool and build on top an example like this to be able to generate a research draft. In terms of some of the technical aspects of the project here, what you'll be able to do is you'll be able to add your own resources as well. And if you don't put in any resources, where it's going to be reaching from those sources is from something called Tavily. So Tavily, this is going to be our search API. This is going to be how we break up our query. This is going to be how we get that most recent up-to-date information that we can ultimately feed into the response and within our application itself. And in this example, I'm going to be showing you how you can set this up with an OpenAI API key. Just a couple housekeeping things. This example is going to be using the 3.12 or higher version of Python for our LangGraph architecture on the back end. For the UI layer of our application, just make sure that you have a recent version of Node.js installed for what we're ultimately going to be using. We're going to be using Next.js in this, but just make sure that you do have a recent version of Node installed so you don't run into any issues when we run through the installation steps. The first thing that I do want to mention is I'm going to put a link to the repo within the description of the video. All that you need to get started will be within the readme.md. The way that this is going to be broken out is we have our UI layer. This is going to be our Next.js application. And then we also have our agent architecture. These are going to run independently of one another. You can deploy your UI basically anywhere that you can deploy a Next.js application. Now, in terms of the agent architecture, you'll be able to deploy this wherever you can run Python, or alternatively, you will be able to run this within the LangGraph Studio, which I believe is still within beta. But if you do have a paid account for something like Langsmith, you will be able to try this. The first thing that we're going to do is within our UI layer, we're going to put our OpenAI key within this. That is the only environment variable that we need within the .env. So just make sure you make a .env, you put in OpenAI underscore API underscore key, and then save that out. Now for our agent architecture, we're going to be setting up a .env within here. We're going to be putting in our Tavily API key. For Tavily, it's Tavily underscore API underscore key. And for OpenAI, it's OpenAI underscore API underscore key. And then you can save out your .env. Once we're within the UI portion of the application, you can go ahead and npm install everything. Within here, we have some dependencies from CopilotKit, as well as some styling libraries, as well as things like OpenAI, as well as a handful of other things like the Tailwind dependencies and what have you. Within our app directory, we're going to create a route at API/CopilotKit. And within here, we're going to go within our route.ts. The first thing that we're going to do within the route is we're going to import a handful of dependencies. We're going to import a handful of things from CoPilotKit as well as OpenAI. Once we have that, we're going to initialize OpenAI as well as set up the adapters. We're also going to be setting up the Langsmith API key. If you do want to have Langsmith tracing, you will be able to have that as well. This endpoint is going to be set up as a post request. Within the post request, we're going to be setting up the search parameter, but we're also going to be setting up the deployment URL. Depending on where you have your LangGraph architecture deployed and where the agent is deployed, that's going to dictate where your deployment URL is. Now, Langsmith, like I mentioned, this is going to be for tracing to be able to see and debug all of the different pieces within your application. From here, we can set up the different agents that we have within our application. In the example that I showed you, we're going to be leveraging the research agent. One thing that I do want to call out is for the environment variable, we do have the ability to set the remote action URL. So this is going to point to wherever you've deployed your Python agent architecture. This can be completely separate, like you could have this on a render instance, and then you can have the Next.js application on something like Vercel or Netlify or whatever it might be. You can have those pieces and really decide wherever you want to put the two of them and make them communicate to one another. Once we've done that, we're going to initialize the CopilotKit runtime to our remote URL right here. Finally, we're going to be handling those requests, and that's going to be what ultimately gets sent back to the UI portion of our application to be rendered. Next, we're going to go within our page.tsx. Within here, we're going to be setting up a client component. Again, we're going to be importing a handful of dependencies, so some from the CopilotKit library, and then we're also going to be importing some of the components that I'm going to show you within the page.tsx. So this is a single page application. This is going to be effectively the highest point outside of the layout itself. The layout, it's the typical Next.js layout. We didn't touch that at all. But for the page itself, this is going to be like the shell of our application. Within here, we're going to be loading up a number of different dependencies like CoPilotKit, but then we're also going to be importing a number of the components that I'm going to show you right after this component. Within here, it's a pretty simple component. We're going to have our model selector like you saw, and then we're also going to be rendering adjacent the home component. The home component is like the shell of the shell. That's going to be the main component that has the subsequent children components, which have all of those different pieces like you saw within the UI of the application. Within the home component, the important piece here is we're going to be using the selector context. Within this is going to be how we access the context of the agent, whatever that agent is doing and the various states that's happening on the back end, those are going to be sent down as the agent props within the CopilotKit component. And that's going to be ultimately sent into our application and how it has the context of what's happening. Within the main.tsx, the first thing that we're going to do is we're going to be importing a handful of things. Once again, here we're going to be importing the research canvas. And then we're also going to be importing a handful of things from CoPilotKit. Again, we're going to be getting the types for the agent state, as well as the model selector context, like you saw on the bottom, being able to select between OpenAI, Anthropic, as well as Google. Within our main component, we're going to be setting up a handful of hooks. This is going to be how we initialize the initial state of our application. Within this component, we're going to be keeping track of the model itself that we're going to be using, the agent state, and then we're also going to be setting the initial state here. So we're going to have logs, reports, research, the research question, all of those various component pieces that you saw within the UI. This is the initial state here. Now, if you did want to preset some of those things, you could also do that within this initial state as well. Next, what we're going to do is we're going to be setting up the default chat suggestion. You might not have caught it, but on the outset of the video, this is set up for an example to show about the lifespan penguins, just as an example's sake. But this could be whatever the use case that might be specific to what you want to build out a research canvas for. Once we have that, we have some simple JSX. So we're going to be rendering the title. Below the title, we're going to be setting up the research canvas, and that's going to be where we have some of the other component pieces there. We're going to be setting some styles. And then finally, we're going to have the Copilot chat. The Copilot chat is going to be that right-hand pane, and that's going to be your Copilot, where you can have your conversation. And depending on what you do within that right-hand chat panel, it will reflect and update the changes within the UI. Within the components, we do have a handful of ShadCN UI components. I'm not going to be going through those. Instead, I'm going to be going through the core components. These are the blocks of the different pieces that you saw on the outset of what make up the application. The first thing that I'm going to show you is the research canvas component. Within this component, we're going to be specifying to use client since we're within the client side. And this component is going to be where we leverage most of the final components that I'm going to be showing you within the video. The first thing that we're going to do is we're going to be setting up the research canvas component itself. Then from there, we're going to be reaching for the context that we wrapped our entire application in. Once we have that, we're going to initialize the co-agent state. And then from here, we're going to be setting up some helpers to show some different states for what the UI is doing within our application, depending on the state and where it is with its particular status. For instance, if we don't have any state for the logs, we're going to go ahead and render this progress bar here. Then from there, we're going to have the use Copilot action. Within here, this is going to be the confirmation to the user to make sure that they actually do want to remove that resource. If they end up clicking delete, that's going to set the handler to yes. Alternatively, if they click no, it will just exit out of that. In the application, you saw that the Tavily responses do ultimately get streamed in, but you do also have the option where you can manually those as well. We have a number of pieces of state to actually update those, as well as have them stream in, depending on whether it's the Tavily implementation that's coming back and streaming in those responses within the UI, or if it's a user that's manually setting individually all of those different resources that we're ultimately going to set within the state of the UI layer, which will be sent to the backend and ultimately communicated to the backend agent architecture. From there, we just have a function to add a new resource. We do have as a conditional check is just to make sure that we at least have that URL, and then we'll be able to set the resource URL. And then alternatively, optionally, if you have the title as well as the description, that will be set in the state as well. We have a simple function to remove the resource where we're just going to filter through those results on the particular resource that you've selected to remove, if you happen to do that. Finally, we have a handful of hooks on how we can set some of the different pieces that we're going to use within the state. Next, we have a simple handler for when you click the card itself. And then we also have a function for when you do happen to update the resource. Finally, within our render component, what we're going to have within here, we're going to have the research questions. This is going to be whatever you might be researching, you can put in that context. Within this, we're going to have the input. It's going to have the context of whatever you put within the input there. And then from there, we're going to list out all of the different resources. Here, we're going to have the edit resource dialog. I'll be showing you that in just a moment here. We also have a handful of props, which you'll see when we go through the component. We also have one for adding a resource. I'm going to go through that as well. And then we also have another condition here for the resources component itself. Again, I'm going to be showing you this in just a moment. Finally, we have our research drafts. This is going to be where we render our text area. And within the text area, this is going to be what the research draft is. When we get that information back from our agent and it streams in based on the information that was passed into the LLM from Tavily, which ultimately gets sent in and returned back as Markdown. That is arguably the biggest portion of the application. It holds the main pieces. This is largely what's the parent context of a lot of the UI state. It was a little bit involved, but for the other pieces, they're smaller component pieces. They're not quite as involved. I'm going to go through them relatively quickly, and then we're ultimately going to move to our agent architecture. And that's going to be a lot of the logic on how we communicate with LLMs. You'll be able to see the different pieces on how all of that works. Within the progress TSX, this is going to show different intermediate state depending on what the application is doing. Depending on the logs that we send back, it's going to map that particular step, and we're going to see that progress step item. As you put in a query and you saw the different pieces of it parsing different requests from Tavily, and it's starting to list out the various web pages, that's effectively what's going to be showing in the logs here. It's nice to just have a log state where depending on the state of the logs, you can just show whatever is there. There can be multiple pieces within that, and it can vary in terms of what is actually shown there. But if you want a standardized log to show, this is effectively what you can do with a progress component just like this. From here, we're going to be connecting the lines between these steps. If there are multiple steps, like it's searching multiple web pages, it's going to do that. And then there are a couple sort of helpful pieces here just within the UI to parse through things like the URL to make them look a little more visually appealing. Next, our model selector. So not a particularly exciting component. Effectively, all this is doing is if you do have multiple models within your application, you'll be able to select the particular models. If you're using OpenAI, you can select OpenAI, alternatively Anthropic, Google, and you can also add others as well within the model selector if you'd like. Next, this is the component to add the resource dialog. Again, we're going to be importing a handful of things here. We're going to be setting up the types for this, and then we're going to be setting up the component itself. This is going to be when we add a resource. If you want to add in a new resource, we'll just have to have the resource URLs. You can add in the title, you can add in the description, and those are going to be all of the different pieces that ultimately get sent back and that you can use to fetch as context if you want to have also some sort of hard-coded pieces in addition to what Tavily is going to be reaching for. And then finally, you also have the submit button, and that's going to be what ultimately adds that within the state of the application. When you do send in that request, it can grab this particular resource. Next, I'm going to be setting up the edit resource dialog. Within this, we're going to be again importing a handful of dependencies. We're going to be defining some of the props and interfaces for the different types that we're going to be using within the application. Within our component here, this component is very much similar to the add component. We're going to have the ability to edit the resource URL, edit the resource title, edit the resource description, just like you guessed, and then finally actually saving it out for once we're done. For our last component, we have the resources.tsx. We're going to be importing a handful of things. We're going to be setting up the interfaces as well that we're going to be using within the component. And then within here, this is going to be the parent component to where all of the different resources are. We have a card as well as the card content for each of those different resources. We walk through the steps on when you add that and edit it, and you have that dialog that pops up where you'll be able to put in the particular information. This is going to be the component of where all those pieces that you add or edit or ultimately get streamed in are shown as almost like that block level element across the screen there. I think it showed about 3 or 4, and that's going to be what this component is. Within here, we're going to have the resource title. These are all going to be dynamic dependent on whether they're coming in from Tavily or if you've set them up manually and inputted them. Within here, we're going to have the card of all of those different resources that we're using as context that we ultimately leverage within that final piece within that text area where we have that markdown. That's pretty much it in terms of the UI. Now we do have some utility functions that we have referenced within some of that logic that I just showed you. We do have this function to truncate URLs. We also have a types file where we have some of the things like the agent state for the core component pieces of the model, the research question, as well as the report resources, as well as the logs. Then we also have this model selector provider. This is going to be how we map dependent on whatever model that we're going to be using. For instance, say if we want to use Google Gen AI and we want to use that particular agent, you can reference that. That's pretty much it for the Next.js portion. I know it's definitely a lot of different pieces, but hopefully me walking you through this, you have a better understanding on how all of this works. And then to actually run this, you can just go ahead, PM dev, and then you can also find some of these scripts within here. You can see how to build it, how to actually run the development server, how to start it, and all of the different pieces there. Now we can move from the UI portion of our application and we can go to the agent architecture. Now, the nice thing with LangGraph, if you haven't used it before, is you can actually load up this example within LangGraph Studio. If you want to do that, you just have to make sure that you have LangGraph Studio installed as well as Docker. And then once you do that, you can just import this agent directory like you'll have within the repo of the video. If you do want to deploy this, you can deploy this to LangGraph Cloud itself. I believe the offering is still in beta, but this is effectively the configuration file on how to actually set that up for when you pull in your repo. And if you actually want to use that as a hosted production endpoint, you do have that as an option. Similar to how we set up the .env within the root of the directory of the Next.js portion of the application, we're going to be setting up a .env within the agent as well. Just make sure that you do have the OpenAI API key as well as the Tavily API key installed. For the agent, what you can do is once it's pulled down, you can go ahead and Poetry install. That will pull down everything that you need. And then once you have that, you can go ahead and Poetry run demo, and then you should see it running on this port. By the end of it, you should be able to just npm dev, Poetry demo, and that's all you need to have the different pieces of your application work. You have your Next.js layer, and then you have your agent layer, and all of the different pieces within this example are all wired up where you can get started to build on top of this. The first thing we're going to go through is the agent. This is the main portion of our application. This is going to house a number of the different smaller component pieces of our LangGraph architecture. Within here, what we're going to do is we're going to be importing a handful of libraries, and we're going to be importing a couple things from LangGraph as well as a couple pieces that we have shown within the directory here that's similar to the Next.js portion I'll be running through step by step. The first thing that we're going to do is we're going to be initializing the workflow graph. This is the starting point for setting up a LangGraph architecture. You're going to declare your workflow of the state graph, And this is going to be where we pass in the agent state. The way that LangGraph works is you can establish all of these different nodes and how they connect to one another. Within here, we have a number of the different nodes that I'm going to go through in just a little bit, but effectively all that you need to do, you can reference pieces of logic that you have within one file, or alternatively, you can break it up if some of the pieces are a little bit more cumbersome, and just to keep it a bit cleaner, you can reference it just like that. Say for the chat node, for instance, we can import that from the chat.py file, and then you can add it to the graph just like that. The first thing that we're going to do is we're going to be setting up a function. And within here, we're going to get the state of the particular messages that have been sent back and forth. Depending on the messages, we're going to have the user messages, and then we'll also have the AI messages. And then from there, we're going to specify whether the AI message has any tool calls. If the tool call is specified to use the search node, that's how we're going to be leveraging that search node. If it's to leverage the delete node, we can leverage the delete node. If it's not using a tool and we're just using the message and the chat node, we can leverage the chat node. So you start to see how you can use things like function calling in combination with just natural language and be able to reference that and have it broken out in these different pieces. If it's a search query, it can go through the graph and whatever the architecture is. And depending on what the function is, it could go through a number of different hops within the graph. Then from there, if it's not a chat node or delete or search node, we're just going to end the workflow because the conditions have been met. Next, we're going to be initializing a memory. This is going to be what we leverage for checkpointing within our application. We're going to be setting the download as our entry point. We're going to declare all of the different edges and how they relate to one another, how download relates to chat, as well as any conditional nodes. There's the chat node, and then depending on what the query is from the chat node, we could reference the search node or the chat node or the delete node. We're going to add those subsequent edges as well. We're going to be adding the delete node within the graph, the perform delete node, and then we're going to be defining all of the different edges within the workflow. You can think of this effectively how the different pieces within the graph connect to one another. You can see how we have these conditional edges, and within the chat node, like we went through, is depending on the query, is if it uses something like function calling, it could route to these particular nodes, which is conditional based on whatever the query might be. And then finally, we just need to compile that workflow into the graph. And that's going to be what you ultimately see within LangGraph Studio to have these nice visual representations on what the graph looks like. Next, before I go into some of the specific nodes within LangGraph, I'm just going to touch on and tie up some of the pieces around the application. First, when we ran our server, we're actually running this file here. Now, what this file is effectively the fast API. Now, the reason that we have this is going to be the HTTP server that communicates back and forth with our Next.js server. Within here, we're going to be importing fast API as well as a number of things from CopilotKit. And all that this is really doing is this is acting as the layer that's sitting on top of all that we had just set up within LangGraph. Within this file, what we can do is we can set up the different research agents that we have. If you have multiple, you could very well just have one agent depending on what the application is, but you do have the option to have multiple. You can set up the route on where you want to have this interacted with. And then once you have that, you can declare what you want your endpoint to be for the server. Then we'll also set up an endpoint where you can do health checks as well. If you just want to ping the server to make sure that it is healthy and the server isn't down or what have you, we can just have a route for that. And then we're going to be running the server on port 8000 here. So that's just going to allow us that once this is ultimately deployed, or if you're just running it locally, to actually communicate between Next.js as well as the Python environment. Within the state.py, this is going to be where we declare the different pieces of state. We've touched on this already within the Next.js portion, but this is to have the equivalent within the Python environment as well. This is going to show, for instance, for the resources, the URL is going to be a string, title is going to be a string, description, and what have you. You'll basically just be able to see all of the different pieces here as well. And then this is going to be the log, as well as specifying whether that log stream is done. And then finally, we also have the agent state, which we went through a number of times within some of the components, which is going to have the model, the research question, the report resource, as well as the particular logs. Next, we're going to be going through the model.py file. Within the model file, it's pretty straightforward. Depending on what provider you've selected, you can set up and declare whichever model that you want to use. Say if you're using OpenAI and you want to use GPT-4o mini, you can set that. Alternatively, if you're using Anthropic or if you're using Google, you can declare the model that you want to use, as well as configure some of the other settings as well. If you want to play around with some things like the temperature or what have you, you can do that. Now, the one thing to note with this is you do just have to make sure that you do specify whether it's the Anthropic API key, the Google API key, or the OpenAI API key within your environment variables if you're going to be leveraging multiple models. And then finally, if there's an invalid model that was specified, we can just go ahead and log that out. Next, we're going to be setting up the chat node, which is arguably the main portion of how you're going to be interacting with the application. Within here, again, we're going to be importing a handful of dependencies. Now, what we're going to be doing within this is we're going to be defining a number of the tools that we have available for the research agent. Within the function for the chat node itself, we're going to be setting up the configuration. So this is going to be how we emit the intermediate states for what's within the architecture. The thing that's nice with CoAgents and CopilotKit is you can stream intermediate states. Say if there's particular nodes within the backend agent architecture, you can stream out those pieces to be within the UI. You saw that within the application where for the Tavily resources, they were streaming in as they were coming in. For the logs, they were streaming out. All of those different pieces, that's an example of streaming out intermediate state. You don't need to just wait for that final answer, that final LLM response to stream out within your application. You can emit those intermediate states depending on what's happening. From there, we're just going to initialize some of the state variables here for resources, research question, as well as report. Once we have that, we're going to go ahead, process and filter the different resources. When we get the resources in, we just have to organize these because those are going to ultimately be parsed and sent in for subsequent requests. Once we have that, we're going to get the model that we've selected. From there, we're just going to get the particular model that we've declared, and then we're going to actually invoke that model. Within here, this is going to be how we bind some of the tools when we send those into OpenAI. How function calls work is, if you're not as familiar, is effectively they have a natural language mapping that you send in with your query, and it will effectively tell the LLM, hey, dependent on this query, if there's anything relevant within this query that could be sent to a tool call or a tool call be utilized based on the context, go ahead and leverage the particular function call. This could be one function call, it could be zero, it could be multiple dependent on how your application is set up, but that's effectively what's happening there. Then here we're going to be declaring the system message. This is going to be pretty descriptive, just giving instructions that it's a research assistant. And then we're also going to be passing in the context of the research question, the report, as well as the resources. Once we get the response back from the LLM model, we're just going to check whether there are tool calls. If there is a tool call that matches the particular name that we've sent in, we're just going to send in the report. And then if there is something that matches that tool call, we're just going to go ahead and return that result. And then we're going to have the tool messages that we ultimately pass within the message context as well, just so we have that context within the state of our application. Next, within the delete.py file, it's relatively straightforward. This is just going to be handling the deletion of the particular resources. Say on the front end, if we've removed a resource and we ask a subsequent question with natural language, we're just going to remove that from our agent state. For instance, if a user goes and walks through the steps to remove a particular resource, say maybe there's a website that they don't want to reference or what have you, we're just going to go ahead and remove that particular resource and not use that as the context within the query. Next, for our download.py, what we're going to be doing within this is going to be effectively how we reach for those HTTP resources. When we use Tavily, it's going to give us the particular links of whatever we're searching for. But then the next step for that is actually reaching for whatever is on the web page and then parsing those. So getting it to be from HTML to text, because within the LLM, you can pass in HTML as a string. but you're going to be passing in, frankly, a bunch of stuff that you just don't need, right? Whereas with the HTML to text, you're just going to be sending in the relevant pieces of information that an LLM can parse. You're going to be saving on tokens and speed and all of that. Effectively, what this does is we're just going to be declaring a user agent. You can think of it as. And then what we're going to be doing from here is we're going to be reaching for that resource, which is going to be the URL. And then we're just going to be performing some of those helper functions. Within this, we're going to reach for that, get the text, get the whole response back, and then we're going to be converting that web page to text. And that's going to be what we have within the state that we can ultimately pass within the LLM. What we're going to do is we're going to have the state for the resources, and then we're also going to be keeping track for the logs as it runs through parsing each different URL, the resource of the URL that you put in. It's going to work through those and it's going to show those within the logs that you have within that Copilot on the right-hand side there. Effectively, how this is going to work is we're going to go through the different resources. We're going to see which resources need to be downloaded. We're going to log out the different pieces as well. Here's an example of the intermittent state that we can stream back. And then we're going to loop through all of the different resources, and then we're actually going to call that download resource and pass in the URL. Once it's done, we're going to set the log state to done, and that's going to indicate to our application that we can move on to the subsequent pieces. Again, we can emit the state for the download progress as well. And then finally, we can return the final state. And finally, our search nodes. This is going to be what does quite a bit of work. We're going to be leveraging the Tavily API, like I mentioned at the beginning of the video. We're just going to initialize the Tavily API. Now, what's going to be important with this is we're going to indicate to extract the 3 to 5 most relevant resources from the search results. And then once we've set that up, we're going to have our function. We're going to set some of the state variables, and then we're going to create logs for each query. The way that this is set up is we are going to be making multiple requests to Tavily depending on the query. And then within this as well, we also have an example on how we can emit that state on what gets sent back to the application. For the search results, we're going to organize them all within this array here. What we're going to do is we're going to loop through the different queries. We're going to extract all those queries. And then once we have a response back, we're just going to be appending all of those different responses within this array here. Finally, once it's done, we're going to indicate that the logs are done and then update that state once again. From there, what we're going to do is we're going to get the model. And then once we have the model, we're going to send in that request. This is going to be where our system message, we're going to say extract the 3 to 5 most relevant resources from the search results. Depending on what we get back from Tavily, we have our search results here. All of the different responses are going to get appended here. And then we're going to be sending it into an LLM, and we're going to be basically saying, like it says within the system message, just get the 3 to 5 most relevant resources. If you're getting 10 or 20 resources back from Tavily, and maybe a bunch of them aren't relevant, right? You can just filter through some of that noise. That's what effectively this portion does here. Finally, we're going to be clearing the logs and updating the UI. Again, we have another example of emitting that state from one of the nodes. And then we're also going to be processing the extracted resources. Once we get the response back, we're just going to process the results. Finally, we're just going to be updating the state that we've added the particular resources, and those are now within the context and state of our application. That's pretty much it for this one. I know there was a ton that I went through, but I wanted to really go through in depth all of the different pieces on how you can set this up. Hopefully you understand the different pieces on LangGraph, CopilotKit, and how you can begin to build out these new applications with the two. I think there's going to be a ton of different applications where it's going to be more than just natural language in and natural language out. I think more and more we're going to be controlling these applications, being able to reference context within the application, update the application with natural language or vice versa, and it just be more and more prevalent within the applications that we build as well as use. Hopefully you found this video useful. If you did, please like, comment, share, and subscribe. Otherwise, until the next one.